Hey everyone, welcome back to AI from the Ground Up, your go-to series for building large language models from scratch. And we are explaining it in the best and simplest way possible. So in our last episode, we created a tokenizer to split text into individual tokens and build a vocabulary. But then we skipped over one small line of code that has a huge impact on how well your model performs in the real world. That line is actually token, and today we're going to unpack exactly why it's essential. So then we'll test our tokenizer on a real input so you can see how it all works under the hood. So let's dive right in. So I'm actually talking about this very simple line of code. So self.uniquewords.append. So this line might look small, but it actually has a very huge importance. So here we add a special token called unc or unknown. So now you might ask me, why do we need to have this? So well, imagine you're building a language model and it encounters a word, and that word wasn't in the original training data. So something misspelled like Philippines or a brand new slang term. So for now, we actually have a lot of slang terms that are not actually a standard English. So that's why this kind of word or token is very important. So the model has never seen it before and doesn't know how to process it. Without a plan, your model could crash, behave unpredictably, or give nonsense outputs. So that's where unknown comes in. So first, it acts as a catch-all for any word that's not in our vocabulary. So instead of panicking, the model says, I don't recognize this word, but I know how to handle unknowns, and it uses unc token as a placeholder. So this means your tokenizer becomes error-proof. So even when faced with rare, new, or misspelled words. Second, it helps us to keep the vocabulary size fixed. So in a real-world training, we want to control how big our model gets, and if we kept adding new words every time, the vocabulary would ground endlessly. That makes the model inefficient and harder to manage. So we define a fixed vocabulary up front and make everything outside to it unc or unknown. So we can actually use other token depending on what you want it to be. Like for example, end of text. In my case, I'm using end of text, or you can also use unc like this. Okay, you can have like that. Right. This helps with memory efficient training speed and model scalability. And third, it makes the model more general and robust. So sometimes skipping the detail of rare or noisy words and replacing them with unc or even end of text actually helps the model focus on more important patterns instead of overfitting on irrelevant outliers. So this encourages the model to learn meaning, not just memorization. And then finally, it's standard practice in NLP. So everything is serious tokenizer. So whether it's a GPT, BERT, Roberta, or your custom LLM. So include some version of this token. So even though it's just one line of code, it's a critical design choice that makes your model production ready. So it's amazing how simple or how something so small has a massive impact on reliability, performance, and resilience. So now let's try it out. So too much for the reason. I think I have given you enough already why we have to use unknown token, onc token, or even end of text token. It's up to you. Now that we understand how our tokenizer handles unknowns, so actually we are just using here a placeholder. So let's test this with a real input. So now we have here the text 1, hi, I am from the Philippines. Would you like to visit? Text 2, the country is beautiful and the people are kind. So text, so we combine them. And between these two texts, we have end of text and then text 1, text 2. So maybe you would want to ask me, what is the difference between the end of text here and then the end of text here? It is used to be unc. So this one's supposed to be unc, all right, so that we would not be confused. So end of text again, means that a certain text is ended and then there is another text. So it's in between two texts. So when we combine them, we have, hi, I am from the Philippines. Would you like to visit? Then you can see your end of text. The country is beautiful and the people are kind. We're creating two sample sentences to join them. So this is actually a common pattern in LLM training. So it signals where one chunk of text ends and another begins. So this mirrors how models are often fed data in batches, like multiple messages in a chat or multiple lines in a document. document. So this is especially so true when you're processing different documents. So here we initialize the tokenizer and encode the text. So what we get is a list of token IDs. So these numbers represent the words and punctuations. So these are what the model actually learns from. Now we are printing the first 10 gives us a snapshot, and the total count gives us a sense of the sequence length. So which is super important when batching data for training. So it's a sort of a batch training. Then finally we print this one. Finally we decode those token IDs into readable text. So thanks the logic we added, especially the post processing with the regex, so we get back a clean, properly formatted sentence. So with punctuations and spacing looks just right. So even if we had added a completely unknown word like Sylvian, it would have been replaced by Ankh. So now our tokenizer would still work perfectly. So there you have it. We've added a small but powerful tool to make our tokenizer more robust, and we've seen it work in real text. See you in the next episode.